Alright guys, this is section 6.3, trigonometric equations, part 2. In this section we're going to be solving trig equations that are involving half and multiple angle equations, and these often require us to adjust the solution interval to fit the domain. Alright, so this is example 1 from the book. We are solving. So I take a different approach. I'm going to look at changing and adjusting my interval a little bit later. Okay, so if I look at this problem, I see that if I divide by 2 on both sides, I will get sine of x over 2 is equal to 1/2. Alright, so at this point, what I'll do is I look at my, I look at this as being theta, okay? So just bear with me for a second. So we know that sine of theta is equal to 1/2, alright, over the interval of, or not over the interval, but at these two values, when theta is equal to pi over 6 and when theta is equal to 5 pi over 6. Now, and then also when theta is equal to, add 2 pi to this, so when theta is equal to 13 pi over 6 and add 2 pi to that, so then it'd be 17 pi over 6 on this side. So this is where the interval comes into play. Okay, so you need to make sure and keep in mind that you might have to change your interval. Okay, so watch out for the interval. And I promise we'll get back to this fact that this is pi or x over 2. So watch out for your interval here. Alright, in this case, we know that x is going to be less than or equal to 0 and, or sorry, greater than or equal to 0 and less than or equal to 2 pi because of this statement right here. Now, we are looking at x over 2, okay? So to get the interval where x over 2 is concerned, we'll divide our interval all over 2 here. Alright, so then we get a new interval of 0 to pi, okay, when you divide it out. Alright, so from 0 to, because this right here is equal to pi. Alright, so then we are going to only be looking at the values in quadrants 1 and 2 in one time because this is from 0 to pi here. So we're not going to have these extra values. Alright, so now what we're doing is we're looking at, let's see, what color have I not used? I used purple yet? No, yeah. Okay. So we're looking at when theta, like we said, is equal to, when theta is equal to pi over 6, or when theta is equal to 5 pi over 6. Now what did we say theta is? We said theta is equal to x over 2. So our new problem, and when we're solving for x, is going to be that x over 2, because this is where we said that, the x over 2 is equal to pi over 6, and when x over 2 is equal to 5 pi over 6. So if we solve for x by multiplying, we get when x is equal to pi over 3 and x is equal to 5 pi over 3. Okay, so in this given interval right here, we'll double arrow that guy, your solution set is going to be pi over 3 and 5 pi over 3. Alright, and then the next slide we're going to do for over all intervals. Okay, so all solutions next, using some of this stuff. Alright, so last problem we found that x is equal to pi over 3 and 5 pi over 3 over the interval 0 to 2 pi. Now, when we reiterate, so we're trying to find all solutions now, so we're finding all solutions now, and generally we're going to look at, and we'll just look at this one for a second, so pi over 3, we're going to look at when, if we go around one period, when do we get back to that value, and same thing for here. If we go around a whole period, when do we get back to that value? Now generally we add 2 pi in to whatever value we have, because the period is generally 2 pi. Now in this case though, what is our period? Okay, our period, since we have sine of x over 2 is equal to 1/2, or yeah, so our equation is sine of x over 2. And I don't want this part here, I want that to go away. Okay, Okay, so if we just look at sine of x over 2, this is our b value, or our b value is equal to 1/2, all right, because b is the number that's being multiplied by x. So then our period is going to be equal to 2 pi over b, all right, which would be equal to 2 pi over 1/2, which is equal to 4 pi. All right, so in this case, our solution set for all values, we would have pi over 3, okay, plus the period, so 4 pi times n, where n is any integer, and also 5 pi over 3 plus 4 pi n. All right, where n is any integer. All right, and let's add on those brackets there. Whoopsies. Okay, you know what that's supposed to be. And that's your solution set for all the values. Hi guys, so this is example 2 from the book, and this is the last example we're going to do in the video. So in this problem, you are trying to solve for x over this interval. Now there are multiple ways to do this problem wrong. I'm going to tell you what not to do. First off, we cannot just divide by 2, okay, because cosine of 2x, all right, if you think, oh, cosine of 2x divided by 2, that's equal to cosine of x. Wrong. Okay, this is wrong. You cannot do that because 2 is not a factor of cosine of 2x. All right, the only way to change cosine of 2x is to use your identity. Okay, so this is wrong, so you don't want to do that. You want to use your identity. And we will do that in a second. I cannot spell and write at the same time. I don't know how Khan does this. I-D-E-N-T-I-T-Y. Gosh, failure. You use the identity instead. Okay? So, and what identity am I talking about? That cosine, and actually I would like to put this in a different color. Alright, that cosine of 2x is equal to, and actually there are multiple ones for cosine of 2x, okay, but cosine of 2x is actually equal to cosine squared minus sine squared. Okay, so if we look at that, or it's actually equal, yeah, like I said, equal to a lot of things, but it's equal to cosine squared x minus sine squared x. But in this case, we're actually going to use the identity that it's equal to 2 cosine squared x minus 1, because we don't want to get sine in the mix. Okay, we don't want to incorporate sine in the mix, so we're not going to use this one, that top one. We're going to use this second guy. All right, but before we get there, another thing that you might think to do that is also not a good idea is if you thought, well, maybe I will go and I'll take cosine of 2x equals cosine of x, and I'll divide by cosine of x, so I have it on both sides. Okay, and then I get equal to 1. Well, first off, you have you cannot divide by 0, so you're not going to be able to have values of x that are equal to any multiple of pi over 2. Okay, so or any odd multiple. So 2n, there we go, plus 1. Okay, so any odd multiple, you're not going to be able to have x, because that's when the denominator is going to be equal to 0. Okay, so that's not okay. All right, so then you're going to be losing values as well. So, and then what are you going to do here? This is not equal to this, which we just decided, so you're kind of stuck. All right, so the way to go with this problem is, like I said, to use your identity right here. All right, this guy. We are going to replace the cosine of 2x, I'm just rewriting the problem, with 2 cosine squared x minus 1 would be equal to cosine of x. All right, and then, as with all functions like this, when they look like they're quadratic, we're going to set it equal to 0. So then we'll get 2 cosine squared x minus cosine x, so I just subtracted it, minus 1 is equal to 0. Alright, now this guy factors, and it factors into, and the way I do it is I look, okay, so I've got 2 cosine of x, and then this place I have cosine of x. So then what two numbers multiply to give me, so this has to be equal to, okay, so the middle number, what two numbers multiply to give me -1, and obviously it's going to be plus or minus 1, so we have 1 times 1 here, and we know that it's going to be a plus here and a minus here. Okay, so those two things when we factor are equal to 0, and from there we're going to go and set both of those equal to 0. So we'd have 2 cosine of x plus 1 equals 0, and 2 cosine, and then cosine of x minus 1 equals 0. Okay, so then we have, if we solve for this for, we get cosine is equal to -1/2, and we have cosine of x is equal to 1. Alright, so then in this case, if we're looking at our solution from 0 to pi, okay, watch out for that interval, keep that in mind. Okay, our interval, I'm going to write in this little space here, is from 0 to 2 pi. Alright, then we'll have that for these problems here, cosine is equal to -1/2 at your values of, so cosine is going to be, so I'm going to draw a little thing here, okay? So cosine's negative in these, in quadrants 2 and 3, alright, and it's equal to 1/2 at, and I think in terms of degrees, so 60 degrees. So that's going to be at 2 pi over 3, okay, and also at 4 pi over 3. And then the only time that cosine is going to be equal to 1 is at pi, or 0, because we're talking in, okay, so yeah, and I made an error at the top. If you look at this problem, it says from 0 to 2 pi, okay, with the parentheses here, so it's going to be, because generally we'd say, okay, at 0 and then also at 2 pi, but because this is not included up here, okay, so, oh, I forgot, we didn't use purple yet, because this is not included, alright, that means we won't have this value here. So our solution set for this problem is going to be, I'm sorry, it's so small, it's going to be, I'll write them in order, to 0, 2 pi over 3, and 4 pi over 3. Alright, that's it for now.